Okay. So today we'll be talking about why is it important to keep streams short. So how to work on the event source system specifics around modeling. So I will start with the confession. And the confession is that event sourcing is hard to teach. Yeah, it is. I finally said that. So now it will be just easier. But before I explain you in more detail why teaching event sourcing is hard, let's start from the beginning. So this is me. In 2003, I'm 18 years old. As you can see from this photo, I was at that time I was a huge fan of Kurt Cobain. You can see that from my shirt and the length of my hairs. But besides that, at that time, I created my first bank account. And just so you know, I have this bank account till today. And let's do some math before we go on. So it was 19 years ago, more or less. If we, let's say that I was making like a three transactions per day during that time, each day. And so let's just do this easier. And let's say that each year has 365 days. So if we get the total, then that will give us 20,805 transactions that happened during that time. I'm not sure if that's the correct number, but that's possible. So if I was making 10 transactions per day, then that would give us over 200 transactions in total. And if I was making 100 transactions per day, then that would give like 2 million of transactions. And of course, making 100 transactions per day for a single person is rather hard. But if we think about the company account, then that might seem to be quite possible. But who cares? Why am I telling that to you? Why? Because even stores care about such stuff. So each of even store care about that. And why do they care? Because that's in the nature of event sourcing. So how event sourcing is working? Let's just reiterate. So we are receiving comment. That's nothing spectacular and the same as we are doing in the other approaches. But then we are getting all of the events from the stream. And stream is a history of the specific record. So each operation that we are doing is resulting in events. So when we are getting all of the events for the specific entity, for example, for the bank account, then we need to apply each of these events to some in-memory state. So in other words, state aggregation. So we are doing that event by event sequentially. And after that, we can get the current state. So for the bank account, that can be, for example, balance. Of course, we would have some more information about the owner, etc. But in general, if we are making if we are getting the incoming transaction, then we are increasing the balance. If we are getting some debit like credit card payment or online payment, then we are decreasing the balance and getting the total as summary. And after that, only after that, we can, based on the current state, we can perform the business logic and as a result, store another event. So event stores in general are append-only logs. So this is also nothing spectacular because other databases, like even relational databases, works like that. Internally, they are using the transaction log or write-ahead log, depending how it's named. But in the context of event stores, typically they are pictured like that. So you have long tail of events, and each of event is added at the end of the tail. But in fact, in event stores are keeping those events a bit different. So they are not keeping that as a huge log of events, but we should think about events and event streams as a dedicated storage structures. So that's closer to how that looks in memory. Just to reiterate, event stores are databases. So all of those events, even though we have this ordering guarantee, etc., then they are stored as a separate streams. So as you see, the events 1 to 3, 1 to 4, where are from the, for example, user stream. Then another events are from invoice, and yet another for another user. If we just rotate that and display that differently, then in fact, event stores are keeping all of the events for the particular streams in the same storage locations. So we can think about event streams as files. So as a set of files where each stream is a separate file. So if we are reading all of the events from the specific stream, then it's like we would be streaming all of the files content. So which is good because it's not like we need to do an additional hops, because event sourcing and event stores have two main operations. One is reading all events from the stream, and another one is appending this event to the stream. Then we can optimize that storage. So event stores are pretty good on reading all of the events from the specific stream because they are keeping that in the same storage location. So you don't need to do those hops. And event stores are keeping an index of streams, and index of streams give us the benefit that if we store the stream ID as some hash, then we can do binary search and quickly get into the specific stream and then load just the bytes that are located together. So also the append only log is in fact an index. So this index guarantees us the order in the context of the whole system. So each event, if we are appending it, it also gets this its own location in the all stream or append only log, which is in fact just an index and reference to the binary locations in the disk. So to sum up, event stores are damn good on getting all of the events from the streams. Yet, long streams, even for the database that is damn good for getting all of the events from the stream, can be hard. So as you can see, short streams are manageable, but that can quickly escalate. And Mikhail Shilkov did a thought experiment in his blog post. And he said that if we are appending one event, then we are doing one IO operation. If we are reading one event, then we are also doing one IO operation. So if we have 1,000 streams with one event, then the amount of IO operation within that time is growing linearly. So that's cool because that's what we would expect. In this line, we are seeing that we are just appending new event to the new stream, and then we are appending new event to new stream, etc. If we have 10 events in the stream, then this line, this green line, is much bigger than the blue one, but still linear, which is also good. So why is it bigger? Because when we are appending event to the stream, then we are making one IO operation because we are appending, we don't have any event there. Then when we are appending new event to that stream, then we need to at first load the first event and then append. So we are making two IO operation. And then if we append to the same stream, then we need to do 3 IO operation, because we need to load those 2 events that we previously appended, and then we need to append a new one. And that grows up until 10 events per stream. So if we have 1,000 streams with 10 events, then it's much bigger, but it's still manageable. If we are having 100 events, then it's starting to escalate, but it's still looking quite close to the linear. So as we can see, 100 events in this thought experiment, we already see that something wrong is starting to be happening. And then if we have 1,000 events, then if you have a look on those lines at the bottom, then those are those lines that you saw before. So we are just increase the 10 times more events, but then it's clearly visible that 1,000 events is just growing exponentially. So this thought experiment is, of course, not precisely how the event stores works internally. But if we take different measurements, etc., then we would got the similar results. So if we have much more events than we expected, then we will have much more IO operation, which means worse performance, worse usage of the resources. Yeah, so that, as you can see, that can quickly escalate. So the first thing that is coming to our mind is, well, that's not an issue. I saw on the internet in one of the blog posts that we should use snapshots. So there, no issue. We will just use snapshots. So instead of just, getting 20,000 events for the bank account just to record the new operation, we would just get the current state of the stream and make business operations and checking variants based on that. So this is our stream, or only a subset of our bank account stream. As you can see, we are in like about 5% of that stream. So let's just reiterate. So if we were just building the straight from the events, then we would be applying the transactions one by one, updating balance, and after that getting the final current balance and making our business decision based on that. If we are using snapshots, then instead we don't need to load all of those events, because we will be storing somewhere, and where we will discuss later on, somewhere the current state of the stream. So as you can see, the current balance for this after this specific event is $500. Then after that one, because we recorded incoming transfer, is 800. So if we store this snapshot somewhere, then we wouldn't need to get the state from the events. So instead of taking this long tail of events, we would be just getting the single record from somewhere. That sounds great, right? So snapshots are neat, snapshots are great. Well, let's have a look. So if we were making snapshot after each event, then we would be making a double unit of storage operations. So if we are trying to limit the read operations and make that faster, then by adding snapshots after each event, we would be making our write operations much slower, two times slower. And of course, that might not be a total blocker and the biggest issue, because in majority of our systems we have much more read operations than write operations, but it's not great. I think that only Ivan is not from Poland, so you won't probably recognize those two twin teen stars, those jolly persons. After some time, changed into our president and prime minister. There was a time where in Poland we have double-headed, twin-headed government. And so as you can see, that can also escalate pretty quickly. So in Poland, we know precisely that double doesn't always mean a double pleasure. So as you can see, if we add to that those 1,000 events, etc., then yeah, boy, it can escalate quickly. But we can say that, well, instead of doing snapshot after each of the operation, after each event, we will be just doing once per some defined time. So for example, once per hour or once per two event, etc. And then instead of just because we cannot just depend on the current snapshot, then we need to at first load snapshot, get information from it, for example, from metadata for which event, after which event this snapshot was made, and then load the following events. So instead of just loading the whole history, we would be loading just the events that happened in this specific period after we created snapshot. But then there is a question, and the question arises. So how often is enough to do the snapshot? So every 10 minutes, every day, every 10 events, every hour, or 100 event, or maybe every type, some certain type of event. And the answer is that we don't know. We don't know what's the best time. We need to check that. And what's more, we might not even be able to define that for our system globally. We might need to think about that and check that for each of the type of our entity and our stream. And it's in fact the hope-driven design. Why is it hope-driven design? Because we hope that we will be right. Like, for example, every 10 minutes. And every 10 minutes can work totally fine for almost the whole year. But if we get Black Friday and then we have a peak of the traffic, or like, for example, why do we say that 10 events is fine? Like, why? How can we measure that? Maybe we can, but most of the time it's just guessing. So the other question is where to store snapshots. So we could store that the snapshot within the same stream, and we could store, for example, in stream metadata, where was the last snapshot made. But then instead of making our stream shorter, then by each snapshot, each additional snapshot, we are making it longer and longer. So again, we are escalating the issue that we are trying to avoid. And events in the different stream, well, that could work. That's some option. But then what about the atomicity? So if we have event store, and then event store is allowing us to store a batch of events, but only within the specific stream. So if we want to store snapshots in the separate stream, then we might be facing issue that we managed to store the event, but then snapshot wasn't made. And for the snapshot, of course, that might not be an issue, because then we would just skip this period of the snapshotting. But if that issue happened during the Black Friday and we didn't make snapshot, then the consequences might be much more severe. And we could store that in some durable storage like Postgres, or and then we are sure that the snapshot is stored somewhere. We could store that in some cache, like in-memory cache or distributed cache like Redis, or we could use some cloud-native database. And each of those scenarios have their own pros and cons, but still we will be facing the atomicity issues. So we cannot guarantee that we will be storing snapshots in the same, and that it will succeed. And of course, if we are using Marten or similar event store, then we might overcome that because Marten allows to use the transactions and store events in multiple streams or multiple, or even make a snapshot as a document in Postgres. But then it's still not the recommended approach, and it's still slowing down our writes. And why, in fact, even snapshots are so popular then? Because it happens that in some solutions, like if we are trying to use the messaging system, like Kafka, Pulsar, Rabbit, etc., as an event store, then we don't have any other option because those tools don't have API like read all events from the stream. We can only publish and we can only subscribe. So we cannot just easily get the current state from events. So the most popular approach is to just store snapshot is some additional storage. But then we are getting even more issues because event stores are databases. You have optimistic concurrency, atomicity. So you know precisely that you are making decision based on the latest state. But in those messaging systems, you don't have that because they are not built from that. But then those solutions are so popular that also there is a lot of articles that are misleading and suggesting the snapshots as a go-to solutions. And even in the messaging systems, we should treat snapshot just as cache. And my running joke is that if you have an issue and you try to solve it with cache, then you, in fact, you have two issues. And we also need to remember about the cache invalidations. So no matter how and which strategy do we choose, and maybe if it's 100% alignment with our storage usage, then we need to remember that at some point, because of some accident or just, you know, random stuff, this cache will finally invalidate. And they tend to invalidate when we have the biggest traffic and when we are making the biggest operation. And then consequences are the worst. And what's more, cache invalidation or snapshot rebuilding is also hard because snapshots are aligned with the structure of our aggregate. So if we are making snapshot, then we are coupling our aggregate structure to the snapshot. And when we are trying to change the aggregate structure, then we need to think what to do with snapshots. And with snapshots, we either, if we store it somewhere in Postgres, then we can do migration. If we have Redis, then we can also try to migrate the snapshot. Or we would need to rebuild the snapshot from the beginning, from the events. But the most common case is that because we are doing snapshots, then we are not taking care enough about our stream modeling. And because we decided to do snapshots because we have too long streams, and as a result, we have streams that are even longer. So the operation costs of rebuilding snapshots is extreme. And it's quite common, for example, in Actor model, to rebuild the snapshots and in-memory snapshot when Actor is started. But I saw many times when, because of wrong configuration on wrong usage or wrong understanding, then actors, like when we are spinning like hundreds or thousands of actors, then we can flood the database and just make it down. So operation costs are really incredible. And snapshots are great until they are not. So we need to remember that snapshots are just like a loan, like a mortgage. We will need to pay at some point about that. And I think that I don't know any person, or maybe one, my friend Andrzej, that is saying that he's pretty happy with using snapshots, because at some point it will cost us a lot. We won't see that on our development environment, but we will see that after some time. So it's really important to try something else. But what else we can do? So the best thing to start is to let's meet with our business. We can organize meeting or this can be in an event storming or even modeling form, or we can just sit down together and discuss in the details how our business process works. And it might appear that what we model in code, so this huge stream with just set of different events around transaction, that we are missing some important, small but important events. And those events, in our case, could be, for example, accounting month closed and accounting month opened. And why those events are important? Because we can notice that those events are in fact an end at the beginning of the cycle, and they are slicing our event stream based on some certain business cycle. So in accounting, it does not work like that, that we need to have all of the transactions and access to those transactions each time we are doing another transaction. For example, in cash registry, we don't need to know all of the transactions that happened in the specific cash registry in the department store. We just need to know to make the business decision. We just need to know about the transactions that happened at the specific cashier shift. And as here, I can imagine, or that's my guess, there are a lot of people here that are, or majority that are working as a B2B. So you are a business owner, and you know that you have the accounting month, and the previous months you can just archive and call it a day. You don't need to have a look on them each day to just make sure what transactions are you making. So if we slice our business case based on some criteria, for example, the accounting month, then it might appear that instead of long stream, we will get a set of pretty short streams. And so as you can see, previously we had just a stream like account 21, where 21 was the ID of the account. And now we have 3 or more streams that are sliced based on month. Each of this stream is starting with the accounting month open. So this is event that is starting our accounting period. And each each stream, besides the current one, so the active one, is ending with the accounting month closed. And this pattern is named closing the books. And that's how that works in accounting. And we can apply this pattern also to other domains, like, for example, a patient. That is, we could, instead of storing all of the patient visits in the clinic, we can store it per day, per doctor. So we can slice it based on the temporal aspect. And here, instead of keeping a single stream with the account and its ID, we can add a temporal part to our ID to make that unique. So it will contain of the record ID, so account and, for example, 21, and the cycle ID, or which can be just a date, or it can be something else like an hour, a minute, or a hash. So something that we define based on our current business use case. And isn't that still too many events? Because as we can see, those streams can still have like 100 events. Well, if you remember this slide about how event stores are keeping their streams in memory, then you should know that 100 events per stream is not a big deal, especially remembering that our stream should be rather granular. So only keeping the information about what has happened in this after this particular operation, then we are just streaming a bytes from the specific operation. So it shouldn't be a big issue for us. And how to close the book? Because we already know that we can close the book and slice our events stream and our domain based on some arbitrary cycle. But how to do that? Well, the options depends on our business use case. So we need to talk with the business. For example, we can be closing accounting month and opening as a separate operations. And that might be fine. For example, for the cashier shift, it's also usually not the automatic one. Like the cashier is taking the drawer outside, and then another cashier is just going into and just starting manually putting some cash, etc. So this might be viable, but sometimes, and for the accounting month, that might be also maybe more appropriate, is that we would like to start immediately new accounting month after we close the one. So we can also do, for example, batch operation if our event store are allowing us to do that. So Martin allows us to do that, so we can do this shortcut. In Event Store DB, we would need to do it as a separate atomic operation, which might be fine, but it's also risky as we discussed. So for that, we could use like a publish subscribe and make the benefit of the subscriptions. So we can subscribe to accounting month closed, and then after we got that event, we can do some additional logic and then create a new stream for the new month with the accounting month open event. And the other, and that's quite common, and what might appear from our discussions with business, is that the process of closing a business cycle and starting a new one is not so trivial. It's not like just we are storing an event, we are just making summary and then starting a new one. It might appear that there might be some additional steps needed to just finish the cycle. So for example, someone needs to manually approve disclosure, someone with the certain rights, or we need to generate some report. And then we might not want to keep all of those events in the cycle period, because, for example, we would like to have a specific history of this closure as a separate stream to have a clean history, or the closure might take a lot of time and might produce some additional events that are important in the context of the closure process, but are not so important in the context of the accounting month. So instead, we can just subscribe to accounting month close event and then close the accounting month. So as you can see, we are not doing the closure here, but we are initiating the closure process. And after that, we are just closing when all of the steps that are needed were done. And I can call myself a lucky person, because my business, since the beginning, when I started to work with my system, they were repeating us that they don't care what happened during the day, unless we have everything summarized and complete at the end of the day. And my business domain was hospitality, and so hotel management. And there, at the end of the day, some person needs to verify whether all the people that have the reservation for this specific day either checked in or had reservation canceled, or the people that should checked out, whether they really left the room. And if not, if there are some discrepancies, they need to be resolved before we close the business day. So as you can see, this process and this closing the book pattern can be also applicable for other domains. And usually, and that's a benefit in my opinion, because when we are discussing that with business, then we are diving more into our domain, and we can get a better understanding, because most of the business are working like that in the business cycles. So after we close the month, besides just closing the previous month, we can open a new one. But isn't that all too complex? Like, this sounds fine, probably, but it might be pictured as something that is overcomplicated. And in fact, that's how our business usually works. So if we dive into that, then it appears that our domain is a bit complex than we thought. But then there is one trick that we could do to maybe simplify that a bit. And we can still use a single stream. And you can do a face like, what did you just say? Didn't you say like 20 minutes ago that snapshots are bad? And yeah, they are bad. And I'm not thinking about snapshots. So we can design our stream to have some additional part, and we can name it like a current account cycle. And if we found out that we have those cycles, then most of the event stores provide option to truncate events before some specific position. So if we know that we have those periods, then we can say that when we open the accounting month, or in general a new cycle, then we can mark the previous one as obsolete. And we can do that by saying to event store, we are fine with truncating that when you are ready. And instead of getting a long stream, we are getting a shorter stream with the current information. So everything that we need to run our current business logic. Because the most important thing is to remember that the old data and the current data are different things. So the current one are usually those that we need to make our decision, so make our transaction operations. But the old one, usually we don't need them. We are just keeping them for read models, for some audit, etc. So even though they are related and they are together, then they are different use cases for them. And it's really important to think about all of the data that we are using in our aggregates, not only in event sourcing, in that context. So how much of that data do we need to make the business decisions? So what's the difference between snapshot and this event, like accounting month closed? Aren't they the same picture? Well, actually they are not. They look pretty similar, but they are different, because snapshot is just like the name suggests, it's just a snapshot of the specific point of time. It's a technical clone of the state. So it's a one-to-one to what we have in our aggregate. While those events, those are summary events, and they contain information about the result and keeping the context of the business. So for example, accounting month closed is keeping all of the information, all of the summary. So how much cash, for example, if we are thinking about the cashier domain, then we might have the summary of all of the operations that were made during the previous shift, and tender, so the amount of cash we have in our drawer. An accounting month or cashier shift open might just contain information how much cash we have. So it's not like a one-to-one to our aggregate structure. Which in accounting month closed, we just need to keep all of the information that we need to start a new cycle. And accounting month open just needs to have all of the information that we need for the current operations. So it's kind of similar, but the use case and the consequences are much different. And how to close the books with the single stream. And it's not any different from the multiple streams. So we can have a separate operations, but we can here already benefit from the transactions and the atomicity, because each event store that I know gives the atomicity and the transaction boundary for the operation within a single stream. So we can still make that a separate operations if we'd like to. We can do batch, and batch is much easier here because we can do those operation within the same call. So close the previous period and open a new one. And the only thing that we typically cannot is to mark truncation, so mark the events to be deleted, because that information is usually stored in the stream metadata. But yeah, we can probably live with that if we'd like to, but we don't have to, because we can do this batching. We can also do automatic the publish subscribe, and automatic publish subscribe could be beneficial if we would like to mark the previous stream as truncated. So we can store those two events within the same batch and then subscribe for the accounting month opened event, and then mark the events to be deleted. And again, we can also make a dedicated process, and we can keep this dedicated process in the same stream, but we can also keep it in the separate, just to have all of the premises that I mentioned before. So to be sure that accounting that we keep the clean history of this process, and we know precisely when something has happened. So even if we keep the current stream, then we can keep the closing operation for the specific month as a separate stream if we'd like to. But then aren't we losing data? Because I said that we can truncate, we can mark, and tell event store to delete these events when they are ready. And in my past talks, I told multiple times that one of the biggest advantages of event sourcing is that we are not losing data because we keep all of the events and all the history clean. But in fact, when we are marking those events as to be deleted, then we are not deleting them. We are doing the archive process. And archive is not the same as delete. So this is archive. So we are not deleting events anywhere. We are just moving them to somewhere else. And this is deleting. So deleting is just making something evaporate, like those books in the old days. So when we are saying that we want to archive those events, those from the previous cycles, then we are not immediately deleting them. In fact, for example, even StoreDB is not deleting those events when we are marking them as truncate. They are they are only deleted after we run the process called scavenging. So they are still, it's a reversible process, but we cannot by default access them. If we are making the read stream operation, then we won't get those events, but they are still there until we are doing the final deletion. So it's a two-step process. So before we tell event store that, yeah, that's the right time to delete all of the events and that we defined as to be truncated, then we should take those events and move them somewhere. And what is somewhere? And somewhere depends on what we need to do with those events. So if we still need those events for some transactional access, because in some domain, it's not like we close the period and we cannot do any operations based on them. So for example, if we close the, for example, we have an invoice stream. If we issued an invoice then typically we are not changing that invoice. But it might happen for some time that we will be doing a correction. So we will be sending a new invoice based on the previous one. And if we would like to keep all of that within the single stream, to have all of the information about those invoices, then we need to still have this information as active. And sometimes even if we closed the cycle, then, for example, until we opened a new one, then we should be able to reopen it, etc. Yeah, there might be some business cases that we need to fulfill to still operate on those events. And for that case, we can just move all of the events from this previous period into a new stream, and we can call it, instead of current, we can call it with the name, with the ID of the specific cycle. And then we, for the current set of operations, we are using the current stream. And if we need to access and update and do something in the past dates, then we already know what we are changing. So for example, we are changing the April transactions. And so for that case, we can move those events in the new stream, and then we could still operate on them. Of course, it's not ideal, because if we are doing such copy and paste, then they will be added at the end of the append only log. So the global order might be disturbed a bit, but yeah, we need to live with that. We can store the original positions metadata in somewhere to have access to that. So we can work around that, but we need to keep that in mind. The other use case for archive process is when we need to audit that. So we don't need to change this data anymore. We don't need to do anything special about that. We are, for example, legally obliged to keep this information. And when we get for example, the like a taxes verification or something, then we need to show that we have this information somewhere. And for that use case, we might not need to have like a fancy storage. We don't need to keep those information anymore in Event Store and make it grow. We might just keep it in some blob storage. So for example, disk, or I would probably recommend the cloud storage. Cloud storage usually have the versioning capabilities, so we can we can have a history of those archives, etc. So when we get the request to get those information, we can get them from blob, and even if we'd like to, then we can even append them again into Event Store. The other use case is read access or search. So that's probably the most common use case. So even though we don't need those information for the old use cases, so for updating the old cycles, we might need to still get those information for reading, or we would like to just be able to query those events to do some analytics, etc. Then instead of keeping those events in the current storage, then we might want to move it somewhere else. The most common and the most obvious solution is to move events to Elasticsearch, because that should give us the good analytics capabilities, but we can also keep them in our any other favorite storage, or we can store just a projection results, so interpretations of those events, in fact, if we don't need them anymore. And of course, if we need those events, we don't need them, for example, for audit purposes, we don't need to search them, we don't need to for transaction purposes, but we need them for some operations like rebuilding projections, because we would like to still be able, in case we have some bug in our projection logic, or if we just want to recreate projection based on the new logic, just from the data that we haven't used so far from events, or just generate a new set of events, then we can move those events to some another event store instance. And then we are keeping our current transaction instance thin as possible. So we are just using the storage efficiently, and we are getting the performance benefits of the short streams and small storage. But we can still benefit from the same capabilities and the same operations infrastructure, for example, for rebuilds. And in that case, when we have this second cluster, then it might not need to have so many resources. It might be slower a bit because we are not accessing that so much. We can just upscale it when we need to have the rebuilds. And then when we are making rebuilds, then at first we are subscribing to the old store and then to the current one. And then we, thanks to that, we are respecting the order of in which those events were stored. So that's a benefit. So archiving is not delete. And after we applied any of these techniques, we can do the deletion. So for example, run the scavenging process and delete everything that we marked for archiving. And of course, we can use a mixture of that. So we can keep both transactional, or at least for some parts of stream. We can also keep the current data somewhere for audit purposes, and we can keep them in search and for in other event store instance. All of that depends on our use case, on our needs, and what we would like to achieve with the old data. So TLDL, event sourcing is hard to teach, but it's hard to teach because we are using wrong examples usually. If we are opening if we are using the bank account as the first example, then we are immediately need to explain everything that I explained to you today, because an bank account, in fact, is not the most common use case, because typically our entities are living and quite shortly. So, and for example, shopping cart. How many events can you produce on the shopping carts, etc. But some streams and some use cases require us to have our streams longer and longer living. So for those cases, we should still think about the temporal aspect. We should not be just satisfied with the extremely long stream, even though our event stores are damn good at reading long streams. But even event stores, if we are putting too much in them, then they can have a performance degradations if we have too many events. So we should not be cheating and not be satisfied with the most easiest solution like snapshots, because that's just a hope-driven design. It will take us somewhere, but at some point we will just fail, because snapshots are just cache, and as cache invalidation is one of the hardest things that we can imagine. But we have also other operational issues, like how to migrate the snapshot when our aggregate structure has changed, and so on and so forth. So snapshots are great, but until they are not, and they are not pretty quickly, we can realize right after we get to production. So we should, instead of just overcoming and workarounding the issue, we should solve the root cause of our issue. And that usually lies in our misunderstanding or lack of the knowledge about the business process. If we start to talk with our business, then usually we should be able to find out that our business process have those cycles. And believe me, they have those cycles in really majority of cases. And business is not just hiding that from us. They are just, because for them, it's just obvious. But if we ask enough whys, then they will tell us. So, and when we start discussing that with business, then we might find out those cycles. And instead of having like a long stream, we can have a set of short manageable streams. And we can use various tactics like a different multiple streams, but we can still use a single stream solution if we like to, because we can truncate and archive all the events from the old old cycles and just keep the current ones. And archive is not the deletions, it's just moving events from to somewhere else. And in fact, in real life, there is nothing like a deletion. If we take the some junk and we throw it to the trash bin, then it's not magically disappearing. It's just moving to somewhere else. So we should do the same. But the most important is just to keep streams short, because that will help you and that will make your life easier and more effective. So thank you. That's all from my talk. And thank you for joining this webinar. And now we will have a time for questions. I will stop recording so we feel a bit more comfortable to even ask potentially dumb questions, but of course, there are no dumb questions. And for those people that will be watching that from the recording, feel free to write me an email or just ask a question on Discord. I will try to answer that as soon as possible. So